Hello everyone, and hi Dad. Happy Father's Day. Here's your video on Hummingbird Evolution. So let's jump right in. Birds are modern dinosaurs, and those feathered theropods are divided into two surviving clades, Paleognathae and Neognathae. Paleognathae includes ostriches, emus, rheas, cassowaries, kiwis, these five are the ratites, as well as tinamou and the extinct elephant birds and moas. Interestingly, debates have raged over whether ratites are ancestrally or convergently flightless. After all, these flightless birds are distributed over separate continents, South America, Africa, and Australia and New Zealand. However, phylogenomic evidence indicates that ratites split after the breakup of Gondwana, meaning their respective ancestors became convergently flightless in each locality, implying 6 separate losses of flight. Neognathae then splits between Galloancerae and Neoaves. Galloancerae contains the land fowl, including chickens, turkeys, pheasants, partridges, and peafowl, and the waterfowl, including ducks and geese. Together, Paleognathae and Galloancerae constitute a whopping 5% of total extant bird diversity. The other 95% is contained within Neoaves. Relevant to this video, we're going to look at the clade Strasores. This clade houses nightjars, nighthawks, patus, oilbirds, frogmouths, and yes, the hummingbirds. Specifically, hummingbirds, as well as the swifts, are in the order Apodiformes. Interestingly, there is a fossil bird from the early Eocene Green River Formation in Wyoming named Eocypselus, which is evidently closely related to, yet falls just outside, Apodiformes, representing what their ancestors may have looked like. According to a 2013 paper, quote, wing morphology of Eocypselus rowi is intermediate between the short wings of hummingbirds and the hyper-elongated wings of extant swifts, and shows neither modifications for the continuous gliding used by swifts, nor modifications for the hovering flight style used by hummingbirds, close quote. And hummingbirds all fall in the Apodiformes family Trochilidae. Molecular clocks estimate that swifts and hummingbirds diverged about 58 million years ago in the Paleocene epoch. The modern lineages of hummingbirds began diverging as far back as 40 million years ago in the Oligocene epoch, but hummingbirds underwent a major radiation event beginning around 22 million years ago in the Miocene epoch, resulting in most of the modern clades. Today, hummingbirds are exclusively native to the New World, North, Central, and South America. However, this was not always the case. Fossils of stem hummingbirds have been found in the Old World, notably in Europe and Asia. For example, a 2007 paper reports for the species Eurotrochilus inexpectatus that, quote, its long, thin beak and short and stout humerus and ulna are typical for hummingbirds, but the coracoid resembles that observed in swifts, close quote. From Middle Eocene Germany, Parorgornis, quote, has a swift-like beak, but trenchantly differs from modern swifts in its feathering. Whereas swifts have very long wings and a short tail, Parorgornis combines a short and broad wing with a long tail, and its feathering thus resembles that of owlet nightjars. The presence of a swift-like beak in Parorgornis is in perfect agreement with earlier assumptions that hummingbirds evolved from an insectivorous ancestor, and the owlet nightjar-like feathering may well be a primitive trait of early hummingbirds, close quote. From Russia, the early Oligocene bird Jungornis and the late Eocene Argornis both possess the modified elbow joint unique to hummingbirds, and Jungornis even has a humerus head that would have allowed for hovering flight. From the early Oligocene of France and Germany, the Eurotrochilus fossil possessed a body very similar in size and skeletal proportions to modern hummingbirds, though it falls slightly outside Trochilidae, indicating that nectivory and hovering flight evolved before the Oligocene. The transition from insectivory to nectivory in hummingbirds has had interesting effects on some flowers. Flowers that are bird-pollinated are called ornithophilous, meaning bird-loving, and these flowers have very specific characteristics. According to a 2005 paper, quote, they produce a great amount of nectar, are often colored brightly red, have a long corolla, and do not provide perches near the flower. This last feature distinguishes most New World ornithophilus flowers from those in the Old World, as nectivorous Old World birds are not capable of sustained hovering flight and usually have to sit on branches near the flower or parts of the flower itself while feeding at the nectar. However, it has been recognized by botanists that some Old World plants exhibit a very similar flower morphology to those pollinated by hummingbirds in the New World, although they occur in areas without hovering avian pollinators, let alone hummingbirds. Examples include the Himalayan agapides, the East African Canarina emini, and West African Impatiens sacchariana, as well as the West African Cibicea spiosa and the South African Tecamaria capensis. Discovery of fossil hummingbirds in Europe now suggests that the flower traits of these plants may indeed be primarily an adaptation to pollination by hummingbirds. After the disappearance of hummingbirds from the Old World, their pollination may have been taken over by long-tongued bees and other insects, as many neotropical plants today are still visited by both hummingbirds and insects, close quote. Hence why people put bright red or pinkish food coloring in their hummingbird feeder liquid. It is unknown, though, why hummingbirds went extinct in the Old World. However, there is a family of birds that convergently came to fulfill the same ecological role, Nectariniidae, the sunbirds. The hummingbirds themselves were also affected in interesting ways. To be able to rapidly flap their wings for hovering and fast flying, they have evolved a ridiculous metabolic rate. In some species, their hearts beat over 1,000 times, and they take over 200 breaths per minute. But this came at a high cost. Because they are spending so much energy so fast, they are quite literally perpetually running on empty and are hours away from starving to death. To compensate for this, hummingbirds have to consume nectar constantly, and they consume a lot, often several times their body weight a day. Among modern hummingbirds, they exhibit great diversity both in feather color and bill shape. Some hummingbirds have co-evolved with ornithophilus flowers to the point where the birds have either extremely long bills, like the sword-billed hummingbirds, or downward curving bills, like the sickle bills. In a study on plant-hummingbird interactions in the West Indies, researchers found that, quote, plants pollinated by large, long-billed hummingbirds had flowers with a long corolla tube, large amounts of nectar, and showy orange-red coloration. These attracted few or no insect species, whereas plants pollinated by small, short-billed hummingbirds were frequently pollinated by insects, particularly lepidopterans, close quote. So that's the hummingbirds, diminutive avians closely related to swifts that evolved in the early Cenozoic and have proliferated, co-evolving with flowers. So, thanks for watching, and I'll see you next time.